Good morning, everybody. I don't know, today I'm a bit nervous just because there are sports people around, and I'm a huge nerd, so I'm not really good at sports. So today I'm going to talk about artificial intelligence, its risks and rewards. So what is artificial intelligence? It's basically a buzzword that we use sometimes to visualize future, other times to try to impress people. But if you think about it, it's an oxymoron. It's artificial intelligence. Now, intelligence, by its very nature, is organic and natural. But we call it artificial, probably because it works or operates in silicon-based machines and not carbon-based life forms. And also, it's driven by mathematical models. Now, is it fair to do that? Because if you think about it, we are driven by mathematical models as well, and so is our universe. So we need to really look at what are the similarities and differences between machines and humans to be able to understand risks completely. Now, to look at the differences and similarities between human brain and machine brain, also known as algorithms, machine learning algorithms, we need to understand intelligence and the nature of intelligence, because if we don't understand the nature of intelligence, we are not going to be able to understand the nature of human intelligence and machine intelligence. The problem is there are so many definitions of intelligence. Which one to choose? So I'm going to go through a few good definitions that I like particularly, and try to see what we are good at and what machines are good at. So according to this definition, it's the ability to understand complex ideas, which humans can do very, very well. Machines, on the other hand, not so much. Adapt, we both can do that. Learn from experience, yes, that's how machine learning works, and that's how we work. I'll talk about it a bit later. Engage in reasoning, we both do that, and overcome obstacles. Another one talks about thinking abstractly. Now, that's where machines fall short and humans win. We can think abstractly, we can imagine things, but machines can't, but they can sure learn quickly. The next one, are they aware of the relevance of their behavior to an objective? Yes, they are. In machine learning algorithms, we set a goal for them, and they try to work it out how to reach that goal. And they know if they go left, they're going to be away from the goal. If they go right, they're going to be closer to their goal. So to some extent, they are aware of the relevance of their behavior. They can plan to work to an end goal, so can humans. But the thing is that we can imagine the end goal. Machines can't. We have to set the goal for them. If you notice, we have made human intelligence the baseline. Should we do that? Why do we think we are the best species, or our intelligence is the true intelligence? We have a lot of other species like bees, spiders, bats, deep learning, that are really good at things that we are not. We don't understand their logic. We learn from them, but still we think we are the best species. And maybe it's our arrogance, which is not going to play well in the future if we didn't try to understand artificial intelligence. Right, so let's look at a few types of intelligence and go a bit deeply into how the brain or algorithms work and how they compare with each other. Now, interpersonal intelligence. It's the intelligence of sensing other people's feelings and motives and then behaving accordingly. How do we do that? Well, from the very first day we come into this world, we collect data. How does mom look when she's angry? What does she or doesn't she do when she's angry? Or in your cases, your coaches. And how do we behave to make them happy and get to our goal? You know, we humans are kind of selfish. We are always looking for our benefit on individual level or group level. And that's our motivation to look at other people's behaviors and adjust accordingly so we can get something out of the interaction. So, for example, a baby, if the baby needs to be fed, is hungry, their brain goes into this processing and they and gives a recommendation, okay, try to look cute. So people will, give you some attention. Okay, maybe dad does. So it worked with dad. Great, I'm going to do it from now on. So it's that feedback loop that works between the baby and the parent. But what happens if the baby does the same thing with mom? It doesn't work. Looking cute doesn't work. Okay, let's make some noise. Doesn't work. Okay, let's full-blown cry. Okay, that worked. So the baby understands, okay, with this person, I have to go to extreme measures to get attention and be fed. And that becomes the baby's behavior, and it goes on through life. That's how we are set in our behaviors. But as we go through life, we change because we learn, we interact with a lot of different people, and we learn these things, and we grow. Now, we do know some people who never grow because they never get out of those behaviors, but that's another talk. So, and here comes the question of nature versus nurture. Now, this whole behavior, this whole process of learning and interacting with people, learning from their behaviors and adjusting, it is nurture. It comes from the place we are brought up in, right? So what's nature? Through the human evolution, we have learned certain behaviors. The behaviors that our prehistoric ancestors learned have been transferred to us and make up our, those fight and flight responses. They come from our ancestors. So the behaviors that they learned from their data collection, and they processed them, there were some neurochemicals involved. They were passed down to us and became the part of our software. And there's been a recent development, recent research, which says that our ancestors or our fathers or grandfathers' memories are actually passed down to us. So if my grandfather went through some trauma, or they didn't like a certain object or certain smell because of an experience which was against, again, data collection, it's very much possible that I won't like that smell or object, and I wouldn't know why. And that becomes our nature. We don't know why we hate things. We don't know why we love things, but we do. It's instincts. It's our nature, and it comes from our ancestors. Now, what happens in machines? Same thing. They look at the environment they're operating in. They collect data. In a lot of cases, we give them data, and we give them the goals. They train, they process that data and come up with a recommendation. If the recommendation is closer to the goal, great. If it's not, it goes again and again, and that's like iterative process. And the process repeats until the algorithm is converged, which means it's, the output is as close as possible to the goal. So that's kind of nurture that machines actually do have. Nurture, probably not so much. There could be versions of softwares, but that's about it. And then we have transfer learning, which means whatever an algorithm learned from domain A can be transferred to domain B. Another one is bodily kinesthetic, which is what you guys would know. It's the learning of certain motor skills, like when we try to learn dancing or any kind of sports, when we practice that particular skill, we say we are building muscle memory. But is that muscle memory? It's actually sensors connected to our muscles called proprioceptors. What they do is they detect the movement, certain movement, gather the data, send it to the brain. Processing is done. What the brain thinks is the best reaction to that movement. It sends that information, and then you do that. Now, as much as we practice, we get better and better at these things. So what's happening there? Well, our brain is identifying those patterns. And just thinking, okay, this guy is not going to give up, is doing this every day. I better create permanent connections to support the body. So why does our brain create these permanent connections? Well, the brain is really busy. It has so many things to do. So it doesn't really like to do these things on ad hoc basis, to support your body on ad hoc basis. So what it does is creates these connections, get it out of the way, this whole support system for your body so that it can do different things. For example, when we start learning to drive a car, what happens? We are focusing on the skill. So we can't really focus on the road. We are focusing on looking in the mirrors and handling the steering and the brakes and everything. But as you go through this whole process of learning, it becomes second nature. So now your brain is free to focus on the road and actual decision making. So that's what bodily kinesthetic intelligence is. In machines, does this work? I'll show you this video. Now you can appreciate how it's trying to balance itself with the movement of arms, just like we do. So it's taking those movements through the sensors, same as our body, and processing it, and then coming up with the reaction. Okay, if there is a log in front of it, it's going to jump, and that's coming from its brain or algorithm. Again, pattern identification is being done, movement correction and learning. If you haven't, go and search on YouTube for the videos where people are actually pushing and shoving robots, and they're just falling down. Why? It looks funny, but it's part of learning. So the first time it's pushed, it's going to fall down, but the second time it's going to learn to balance, and that's how these machines work. That's how we work. Now, linguistic intelligence is a bit complicated and interesting. When we say something, we mean something. We want to try and convey our emotions, our vision, our imagination. What are machines doing? It's probably just the mathematical models. And why do I say that? Because I tried to talk to different bots, and as you can see, as I kept asking the bot questions, it just lost the whole train of thought. There was no continuity of thought. So what do you like about it? Literally everything. For example, example of. Another one. So this bot was designed to be like, to support your, what was it called? I actually forgot the name, but it's kind of a psychologist kind of bot. But as you can see, it looks depressed. It's not going to help anybody by being depressed. So what it's doing is learning from behaviors of people that are talking to it, and it's just mimicking them. So it's not really understanding its role, and it's not understanding what it needs to do for other people. Other types of intelligence, very, very quickly, machines and humans both are good at spatial intelligence, which is perceiving and moving in 3D spaces. And logical, machines are logical AF because they are born of logic, and so humans can understand logic as well. The things that machines are not good at are intrapersonal, looking into yourself, asking question who you are or what you want. Naturalist, value of things. Now this is really, really important because, yeah, algorithms can identify us, but do they know the value of humans? If they have to reach a goal, are they going to step on a human to reach that goal? They need to understand what we are, who we are, and what's the value of an individual, a human. So the future is a bit safer for us. Musical. Algorithms have created music. I'll let you be the judge of the output, if that works. Yep. Okay, so the music's there, but did you like it? Not really. There was no melody to it. There was no sense of it's not something that you would enjoy. It's just using mathematical models to create music. What it's learned from Mozart or Beethoven, hours of those recordings. The last one is existential. So where did we come from? Why we are here? What was before us? Things like that. Now, if machines get to this point, I'm going to leave the planet. Because I don't have the heart to tell them that they were born in a coal factory instead of a loving family, right? But it's a long way off. It's not going to happen soon. So based on the analysis that I presented to you, the human intelligence and machine intelligence overlap, but then they have different aspects to them as well. Human intelligence is good at intrapersonal, naturalist, musical, existential. And then the overlapping areas are interpersonal, bodily kinesthetic, spatial, logical, a bit of linguistic, but not so much. But what's on the side of machine intelligence? There's a big question mark because we don't know. We always look at machines from our perspective. We try to judge machines from the type of intelligence that we have. And it's going to be big risk because if you don't understand it, we're not going to be able to devise strategies to make it safe for us. To do that, what we need to do is develop a theory of mind to understand the emergent properties of machine intelligence, classify that intelligence, try to model it so we can probably learn from it, and assess the risks and come up with security or safety measures. Now I'm going to talk a bit about the risks of artificial intelligence, what we need to be aware of when we are trying to come up with AI strategy in our organizations. The first risk is black box algorithms. Algorithms, we don't understand how they work. We give them inputs, we get the outputs, great. They can predict our behavior, they can predict what we like. If I give an algorithm all the music that I like, it's gonna pretty accurately recommend me a song which I would love. But can we go other way around? Can we predict their behavior? No, we can't. So what's happening in black box algorithm is, because we don't understand the workings of these algorithms, we have to change our behaviors to make them happy. For example, if I'm applying for a loan, and the algorithm says, okay, it's gonna give the loan to the people who choose short loan tenor. I have to, and my income is not really good, so I want to go for long tenor. I can't, because the algorithm is not gonna put a tick on my application. So what I need to do is go for as shorter of a loan tenor as I can. As a result, I won't be able to pay and I'll default. And then what happens? It's gonna look at my personality, my background, where I come from, which neighborhood I am staying in, what kind of job I have, and that bias of not giving me loan is gonna be applied to other people like me just because of the issue with the first algorithm. So it's kind of snowballing from one thing to another, one variable to another. And because we don't understand these algorithms, we let it do it. We just follow the algorithms. Another thing that I found interesting was YouTube Kids algorithm. I actually saw a TED Talk on it. What's happening is algorithm only selects certain kind of content. We don't know how it's going to select the content, but what people are doing is trying to get noticed by the algorithm. They don't care how good or bad is the content. As you can see, the content is really bad, especially the last one. But they are trying to create the content that's going to be picked by the algorithm, and this content is being fed to our kids. And I don't know what they're learning from it. Another risk is bias. This is a big one. So what kind of biases are algorithms picking up on? Well, the biases that we have: sexism, racism, ageism, biases against certain professions, certain classes, standing, salary, everything. So when we look at, for example, facial recognition, these three of the top algorithms are 99%, up to 99% accurate when it comes to fair-skinned men, but only 65% accurate for darker-skinned women. And some of you might have seen this Google facial recognition algorithm, which was classifying dark-skinned people as gorillas, which was really offensive. And the bias comes from us, comes from the way we program these algorithms, and comes from the data. Another example, this system doesn't even detect the dark-skinned woman at all. Like, there is no face for it. And it's going to be really bad when we come to driverless cars. I'm really scared because I'm dark-skinned, I'm a woman. I'm going to be probably the first person to get run over by a car. So if you Google manager in Google, Google manager in Google, what do you see? A lot of men. There is one woman, great. If you Google boss, there is one woman. Yay, there is one woman, but she's a psycho boss. Yeah. Now, recently, Amazon's AI-based recruitment system was shut down because it was teaching itself to downgrade resumes with the word women in it. What I find really funny, it's not funny, but you can't do anything but laugh. The team tried to stop the system and remove different factors from the algorithm, from the data, but ultimately decided that it was impossible to stop it from finding new ways to discriminate against females. Like it was going to do it no matter what, right? And which I'm going to talk about in another example as well, is we don't know where our bias is etched into these factors. Even if we take them out, it's still biased. So we really need to understand this. It is a really big problem, but we don't realize it. Okay, this risk I really like. So, for example, this system, Compass, it helps judicial system in United States with the same histories of people. It gives high scoring to people with dark skin. The interesting thing is that this algorithm has 137 inputs, and it's a black box algorithm. It gives an output. Okay, it's an AI system. But then somebody did some research and found out that it's no more accurate than a very simple linear equation with only two variables, age and number of offenses. That's it. It gave the same output. Now, which means that AI systems might not be as efficient as you think. And the other thing is with the bias. Our bias is etched into everything, in all the factors, and it's still biased. So how do we get the bias out when we don't understand where it is? Another risk, feeding extreme or wrong behaviors. How do we do that? By personalization. It's a great thing, personalization. We personalize everything for customers, from shopping, from entertainment, Netflix. It's okay, I like certain kind of shoes, I get those recommendations, great. Entertainment, well, I should look at different genres, but yeah, that's fine, it's okay. But when it comes to news and context, it's not good. Because you're going to be connected to the kind of people who believe in the same things, who think just the way you think. So you don't really have those conversations that make you grow or to be able to get out of your bubble of biases. It's confirmation bias. So I read this article, which was great, on personalization and risk of personalization, and the author said what interests public and what's in public interest are two different things. They really are. Sometimes public doesn't know what's in their interest, and artificial intelligence is just feeding their interests. So what we can do about it? We have to understand what artificial intelligence entails. What kind of algorithms does it have? What do they do? How do they behave? Do we really need these algorithms? Yeah, we have to understand and ask the question, why? Why do we need to bring in AI into our systems? For experts, we need to investigate and devise machines' theory of mind. I talked about it before. We have humans' theory of mind. We don't really understand our brains, but still we have something to go on. We have something to understand our behaviors and our communications. We don't have that for machines. That's what we need to do. Value alignment. Now, what do I mean by value alignment? we always look at our interests. It's not like we don't, but we need to code these values and our interests into the algorithms. And for that, we need to first define our values, ethics, and morals in terms of these systems, not for ourselves, but the systems. And we can't do that if we don't understand their behavior, what we need to stop them from. So for example, if we pull a plug on a machine, what should it do? We have seen this scenario in in movies, that they come back to kill us. But what should they do, if we pull the plug? They shouldn't try to kill us for a start. And what happens if a child pulls the plug? Or if another country, if our enemy tries to pull the plug on our defense systems or nuclear, or try to operate nuclear bombs or something? So we need to code these things into the systems to be a bit safe. Now, you probably know about Asimov's laws. This is my bias working. I'm thinking, okay, do athletes know about Asimov's laws? It's really bad. So it talks about what happens when a robot tries to kill a human. As we have seen, that's not the harm we face right now. That's not the risk we face right now. The risks we face are a bit subtle, are coded in the systems, and we need to come up with the laws for those kind of risks. The future is human-machine evolution together. I'm still very optimistic about artificial intelligence. And the thing that really interests me is the NeuroEmbodied design, which is the prosthetics. So what happens right now is we are able to send signal from our brain to these pieces of equipment to move a certain way. But the best thing would be to actually get signals from this equipment to our brain, so when we step on something, we can actually feel it. And that would be a true cyborg, and it's not science fiction anymore. It can be done. And deep learning can help us with that. Come on. Yep. Second, brain-machine interfacing, which is you connect your brain with these algorithms. Now, just imagine we connect thousands of sensors to our head, and we run a deep learning algorithm on it with thousands of inputs. What happens? It will pretty soon identify what kind of electrical signals, what kind of activity means what in your body, in your behavior, what you're going to do next. It's great, it's awesome. The only thing is, risks, just the risks. The thing that we need to be very careful here is that when you connect brain with these algorithms and with memory and processing power and all of that, human brain is still in the driving seat. Human brain is still controlling these systems and not the other way around, because we can be influenced very easily. That's where our biases come from, But these machines or these algorithms are really logical. They can't be influenced, and that's our weakness, that we can be influenced. So we need to come up with strategies that we are in control of these machines when we are connected and not the other way around. So that was my presentation. Thank you very much for your time.
Thank you so much, Tasneem. That was fascinating. My brain's exploding. We will have questions from the floor, I know it. We have microphones going around, so I can see Andy's right up, first cab off the rank.
Wow, that was incredible.
Thanks.
Just thinking about, I'm not sure if you're exploring this space, but